In this presentation, I'm going to talk about restricting and sorting rows with the where clause. So with our select clause, we list a bunch of columns that we want to select from a table, but then we have to provide some parameters. So the two clauses I'm going to talk about in this deck are going to be the where clause and the order by clause that you see on the bottom in that standard select. So for example, let's say we have a sample table, right? This is a table of books. We have the ISBN, the author, and the title in our list here, right? So we want to work with some data. The first thing we could do, the most obvious thing is, let's say I'm looking for a book that has a specific ISBN. So I can use the equal operator, right? So column name is ISBN, and I want to find anything where the ISBN is 04511911145. Notice I don't have the quotes around that number because it's an integer. It's not a character string, so I don't need the quotes in most database engines. And then I could also find a book where the author is a certain name. In this case, I used Rand, Ein. And this is not going to work, right? So in many database engines, this won't work. And the reason it won't work is because in my table, her name is spelled with both upper and lowercase, but in database engines, upper and lower are not equivalent, right? They're different characters. So I have to use the name in the correct case. Now, and then I get all the books that are written by that particular author. Now, in the real world, I'll talk about this in a second. We might have to deal with that case a little bit different. But so we have arithmetic operators that which we use in the comparison for our conditions. You have equal sign for equal to. There's an example where ISBN is equal to a value, where last name is equal to a specific value. You have greater than. For example, I can show records that have a salary greater than $50,502 a year, right? I could do greater than or equal to, right? So then it has to be equal to 50,502 or more, right? Whereas the top one will start at 50,503 because it has to be greater than 502. And likewise, you could do less than and equal to. And then finally, have not equal to. Different database engines use different syntax. For the vast majority that I've worked with, it's usually the first symbol that you see there. But some use the exclamation point equal for not equal to. Some use the up hat equal for not equal to. So for example, I can show all the records where the salary is not equal to 0, right? Where they have some kind of salary. I guess that would indicate maybe they're not an hourly employee or something along those lines. So those are our arithmetic operators, right? So in the real world, just to go back to revisit this, before I had to get the case right for the author's name, um, in real data, your cases are going to be all over the place, right? You're not always going to know exactly what the case is. And like I said before, lowercase is not equal to uppercase, right? So the database engine always won't make that distinction. I will tell you that Sybase and Microsoft SQL Server, I think that works. You don't have to worry about case, but with a lot of the other database engines, you do. So one trick you could use is use a function, a single row function to make it all uppercase, right? So then regardless as to whether it's upper or lower, it just converts all of the cases to upper, and then they'll be equal as long as it's the same characters. It doesn't matter if it's upper or lower. This won't change anything for what the user sees or the application sees when they get the results. This is just for the comparison operator. We'll look at this in more detail later on when I look at how to when we actually do our select with our row-based functions. But in the meantime, you could do this if you want to not account for upper or lower case, or you can't count on a user putting the correct case in. And this works in most database engines. Most of them have the upper and the lower functions that you can use, or at least some equivalent to that. So it would convert, the upper would convert both to the all uppercase version of the name, and it works, right? So then we always get a result regardless of what the case is. So again, that's kind of the real world implementation. So let's keep going. So let's say we also have some Boolean operators to connect our different conditions, right? So for example, if I have select star from books where the ISBN is equal to a certain value, um, where it's a certain integer, that's only one parameter. But what if I have two parameters, like the ISBN and the author, and I want both of them, right? So I put a Boolean operator between the two. So in this case, it's going to check to see if the ISBN is a certain value or if the author is Ayn Rand. And I get a result, right? So I have my 4 books by Ayn Rand, and plus I have the one by Ray Bradbury because it has that ISBN, because I have the OR operator in there. So here's another way to look at this, right? So here I have the ISBN is 0679764221, whatever, and the author is Ray Bradbury, or the author is Ayn Rand, right? That might not necessarily work because we have to use the order of operations, right? If you remember from 5th grade, math class, we use the order of operations. Now, assuming, so with please excuse my dear Aunt Sally, it's going to start with the parenthetical, then the exponent, multiplication, division, addition, subtraction, right? And Boolean logic falls into this, please excuse my dear Aunt Sally, to the order of operations, right? But a lot of folks always forget the order of operations. It's kind of a pain sometimes, right? So, remember how this all works. So instead of trying to decode order of operations, sometimes it's helpful to just use parentheses, right? So here we're forcing the database engine to evaluate the ISBN and author Boolean logic first, right? And then go and OR that to where the author is Ayn Rand. So then it returns the results that we're looking for. Another example is, let's say you're looking for a list of ISBNs, right? I've got a whole bunch of ISBNs that I'm looking for in my database. So I've got this list. One approach is I could just put a whole bunch of OR statements together, right? So anytime you're ORing a whole bunch of columns that are the same to each other, it makes sense to instead use an in statement, right? So you just say where the ISBN is in this list. That's the same as having 4 ORs, having the 4 in a list like this, right? So that makes a lot of sense to use the in statement instead. And of course, you can see that it would work perfectly fine. You not only can list you can manually list your conditions, right? Like you see here, but you could also select it from another table, right? So for example, I could select the ISBNs from my orders table. So then I only get a list of books where they appear in orders. And that's a subquery. We're going to talk more about subqueries later on. So we'll get to subqueries, I think, in the in a later unit. But you could also do your in statement could, instead of a list being manually typed out, you can just select it from another table, and you can even have a where clause in there. You can have all the things. That's an entire select statement within that select statement for the in clause. So that works as well. Just like you can say where something is in, you can say where it's not in. So in this example, it's only going to show us books where they haven't been ordered yet, right? So that would be the question answered by this statement. So you can use the not in. ISBNs, if you're not familiar, they actually mean something, right? So, for example, the a portion of the ISBN tells you what group it's in. I'm not sure exactly what that means, right? But the first 2 letters is a group, and then you have the publisher, then the title, and then some kind of check digit, right? So, they're kind of meaningful. So maybe I only want to show ISBNs where they're in a range, right? Because I know that anything that's in that range is going to be books that I'm interested in looking at, right? So here we can do a range. We're saying anything where the ISBN is greater than 65,000, but also less than 86,000. Another keyword you could use in place of that is between. So between lets you show records that are between 2 values, right? So you could do the between operator. And also not between. So this gives you everything that's outside of that range, on the peripheral of that range. So just like the in operator, you can put the not in front of it, right? And not is just another operator, right? So or, and not is also an operator. So you can see where something is not a certain value. Here's a problem, though, going back to these operators. If you're looking for records that are null, you cannot use the equal sign for null. So if that's the case, right? So if you're looking for things that are null, you have to use the is keyword. So we would say where the ISBN is null. So not equal null, but where it is null. And you can also say where it is not null. So you can show records that are not null. And it's generally good practice if you're working with columns that can have null values. If you're doing any aggregation or row functions, it's a good idea to filter out anything that is null. Or filter to only show things that are not null, right? So I'll always add, let's say I'm trying to find the average of my ISBN numbers. I don't know why you would do that, but let's just say you are. If there's a null value in there, it's going to return null every single time. So you have to filter them out. So you'll add a where clause where the ISBN is not null, so that that's not in the set and it doesn't screw up the aggregation. So sometimes it's important to use that not null. All right, so moving along, we've got some other operators. So here we're selecting where the author is equal to Rand, comma, Ayn, right? Because it's the exact same format, so it works. But what if I only want where the last name is Rand? So in that case, I can just replace what I'm looking for with a % sign, right? And we're going to change the equal to a like. So when we use the like operator, it's going to use the % sign as a wildcard. So in this case, it'll return all these records because it's going to return anything where the last name, where the name starts R-A-N-D. But what if I'm looking for an author that either has a first or a last name that starts with the letter R? right? So I'm looking for anything that starts with the R, whether it's the first name or the last name. And we know that we always use that comma separated syntax, right? So it's always the last name, comma, first name, right? Comma, middle, or something like that. So in that scenario, I can use my like operator. So I could say where the author is like R percent, which finds anything where the last name starts with an R, or the author is percent comma R percent, right? So you can use that like operator, that wildcard can go on either side, right? It doesn't necessarily have to be in just one spot. You can have those percent signs can be anywhere. You can even have 3 of them, right? I could have a percent, or a value, a percent, a value, a percent, a value, right? And it'll try to find that pattern. You can almost think of this as regular expressions, right? So it works a little bit like regex, but it's a very simplified form of regex. It's just a simple wildcard. So of course that would work, right? And we can also find where it's not like Rand percent. That'll filter out all of the authors that are Rand because maybe I don't like Ayn Rand, right? So I want to get that out of my list here. Kind of picked as controversial an author as I could find for this slide, except for Ray Bradbury. He's not very controversial, right? So finally, let's talk about sorting. You can add an order by to sort your results. So for example, if I do sort by, or if I do order by ISBN at the end of my select statement, it's going to order the ISBNs, right? So right now they're in no particular order, but if I run that query, it'll return my records in the correct order, right? I have it in ascending order, starting with the lowest number going to the highest number. And likewise, if I wanted to start with the highest number going down, you could do that. Use the DESC keyword. That'll start with the highest number going down to the lowest number. So that works as well. You could do it with other fields. I was just doing it with an integer with the first example, but if you do it with a character, with character data, it'll do it in alphabetical order, right? So here we have, they're in no particular order, but when I run that query with order by title, it's going to move Anthem to the top, and we'll have We the Living on the bottom, everything else in between. And likewise, I can go to descending order, in which case We the Living will float to the top, and then Anthem will be on the bottom because it's now in descending order. Okay, so when you do an order by, you can also indicate whether you want the nulls to be first or last. So if there are null values, it'll move them to the top, or it'll put the nulls at the bottom, depending on where you want those, right? So if there are nulls in the list, you have to tell it what to do with the nulls when you do your order by clause. So that's it. So that's basically what select looks like. So we talked about those different parts of the select clause, and thank you for watching.